Hello viewers, I am Kausalya. Today we are going to discuss about how to design a lead compensator using root locus. Right. So the primary step is you have to draw the root locus from the given open loop transfer function. Right. After drawing the root locus, the next thing is we have to find the dominant pole. So how to find the dominant pole? There will be some values like zeta will be given in the problem. Right, with the help of zeta, we have to find the dominant pole. Or else, you see the dominant pole is given by this formula. If you have all these things given in the problem, then we can directly substitute the values over here and we can find the dominant pole. Right. So here the next hint is if zeta alone is given and omega n is not given, right? Then draw the root locus and then find the dominant pole, right? We have already done problems like this. Okay, how to find a dominant pole after drawing a root locus, right? Then the next is step 2. Mark the poles and zeros of open loop transfer function and the dominant pole on the S-plane. Let the dominant pole be denoted as P. As usual thing, while drawing root locus, we will be marking the poles and zeros, right? It is already done. And here, the dominant pole is named as P. That's it, right? We have to locate the dominant pole on root locus and we have to mark that one as P. Then the step 3 is find the angle to be contributed by the lead network, right? So lead network or lag network, whatever may be, we are using this to provide compensation or to give a stable output, right? So here the angle pi is given by this formula, that is angle to be contributed by lead network to make the point P as a point on the root locus. Just while discussing the procedure, it will be like this only, right? But when you move to solve problems, the procedure will be very easy, right? So before telling the procedure, it won't be look pretty when I start directly by solving problems, right? So just look at it what I am saying, that's it. But while solving problem, it will be more easier because we will be mentioning in each and everything as numbers, right? Rather than reading like just like a paragraph, when we solve using numbers, it will be pretty easier for you, right? So just understood, pi is nothing but angle to be contributed by lead network, that's it, okay? Draw vectors from all open loop poles and zeros at point P. Measure the angle contributed by the vectors. Right, we have to draw lines from all the open loop poles and zeros. Then finally we are going to measure the angle. So here the formula for pi is given by sum of angles contributed by poles of uncompensated system minus sum of angles contributed by zeros of uncompensated system plus or minus n into 180 degree. Initially the root locus is drawn only for a uncompensated system, right? So from that just we are calculating the angles from the poles to the dominant pole. Similarly angles contributed by the zeros to the dominant pole, that's it. So here n is an odd integer, this n, right? So that n into 180 degree is nearest to the difference between angles contributed by poles and zeros. Okay, everything when you read a sentence, it will be looking a bit difficult, but don't worry, right? So the next thing is, if the angle contributed is greater than 60 degree, then the compensator is a cascade of two lead compensators. That is, if you are having that angle pi, we are measuring that angle pi here, right? If the pi is greater than 60, then what we are doing, instead of using a single cascade compensator, we are using two compensators, right? So when we use two compensators, then the angle will be divided by 2. That is, for example, if you are having some 80 degrees, you write, okay, then each this 80 degree should be compensated by two compensators. So each compensator will contribute an angle of 40 degree. That's it, right? The next one is step 4. Determine the pole and zero of the lead compensator, right? So here, look at this diagram, right? So this is the location of poles and zeros of a lead compensator we had already discussed, right? And this is our dominant pole P. So to this dominant pole P, we have to draw lines from the existing poles and zeros. So here we are having a pole and here we are having a zero. So just draw lines from this poles and zeros, right? So this is the basic step. Then the next thing is draw AP. AP should be parallel to x-axis. So here there is a point P. I have to draw a line AP. This AP should be parallel to your x-axis, right? Then here we have to connect this origin to this dominant pole, okay? We have to do by ourselves. Then the next thing is draw a line PC to bisect the angle APO. Point C is on real axis. That is, here the line PC is drawn in such a way that to bisect the angle APO. You see, we are having this angle APO, right? And this line is drawn in such a way that we are dividing this angle APO into 2. For example, if APO is some 120 degrees, then we are drawing a line in such a way that this part is 60 degrees and this part is remaining 60 degrees, right? Then the next thing is with PC as reference, right? So with PC as reference, draw angles BPC and CPD. That is, with this point as reference, right, we are going to make another two angles, and one is BPC, this angle, and another one is CPD, right? So that each angle is equal to pi by 2. Again, you see both the angles are same, right? We are drawing line PC such that this angle gets evenly divided. Then the next one is again points B and D lies on the real axis, right? You see they lie on the negative x-axis. And one is pole and it is given by this term, and 0 is denoted as minus 1 by t, right? Find T and alpha from B and D. We are going to find the value of this T and alpha by this B and D, because B we know the value, right? Because it is on the x-axis, it is something like that minus 5.2 or something. Similarly D also. So from these points we can find the values of alpha and T. Then the next one is step 5, writing the transfer function of lead compensator, because we had already find out the value of alpha and T, right? So here this is the basic formula of writing a transfer function of lead compensator. The next step is we are taking LCM. So when you take LCM, you see here both the denominator terms T cancels each other, and finally we are having a simplified expression like this, right? Then the next thing is finding the open loop transfer function of the lead compensated system. So here G of S is the given transfer function and GC of S is the transfer function of compensator. Just now we had find that, right? So this is the open loop transfer function of lead compensated system. So here what is the open loop transfer function from this diagram? Here these two blocks are in series, so just we have to multiply, that's it, right? So here you see, so the open loop transfer function is nothing but GC of S into G of S, right? And finally we are going to find the value of gain K, right? So gain K is given by the formula product of vector lengths from all poles to S equal to ST divided by product of vector lengths from all zeros to S equal to ST. That is, we have to draw lines from the existing poles and zeros to the dominant pole, and this step we had already done, right? We had done this in step number 4. Just we have to measure the length, right? We have to measure the length and we have to substitute in this formula to find the value of gain K. After finding the value of K, the next step is we have to check whether the system satisfies the error requirement. This error requirement will be given in the problem, right? We have to check whether the compensated system meet the error requirement. If the error requirement is satisfied, then the design is accepted. Then whatever the design, the compensator we designed is okay, right? Otherwise, we have to repeat the design by altering the location of poles and zeros, right? We have fixed, that is pole is here and zero is here, right? If the, if the design is not satisfied, then we have to change, right? by trial and error. This is just by our own trial and error method. So without changing the value of pi, the value of pi should remain constant, but we can change the location of poles and zeros, right? Then finally, there is a note here. If the open loop gain k is specified in the problem, then take the gain at s equal to sd as k1. Suppose in the problem, if some gain is given, then we are finding another value of gain k, right, at the dominant pole. In that case, you have to include a term denoted as a, right? So a is nothing but it is the ratio of k1 by k. K is the gain given in the problem and K1 is the gain at dominant pole, right? So now finally, this open loop transfer function G naught of S is written as A into GC of S into G of S, right? So here comes the end of this procedure. It will be very easier when you start solving a problem. Okay, so just have a idea about what are all the procedures, what are all the things to find out while solving. Thank you.